Okay, we're going to talk about the vocabulary of this section, which is what is a function and how does a function and a relation work in mathematics. First up, the definition of a function is that it's a process where an input is transformed into an output. And a lot of people think of it as kind of like a machine. Like you put something in, a process happens, and you get something out. And one thing goes in, one thing comes out. Um, so a function example would be something like this. And the way we say this is f of x. So this is the function f, and it's in terms of x is going to be our placeholder that we're going to plug something into. So this example right here, if we plug 0 in for x, we plug in 0 wherever we see an x in the original function. So this is f of 0 is equal to 3 times 0 minus 1. Oh, and I wrote down the wrong answer. So 3, I wrote it down right. 0, 3 times 0 is 0, minus 1 would be negative 1. So this is the input, 0, and this is the output, negative 1. And the process that it goes through is 3 times some number minus 1. So a couple more examples. If you plug in 5 for x, you would have f of negative 5 is equal to 3 times negative 5 minus 1, which would be negative 15. Minus 1 will give you negative 16. And if you plugged in a variable for x, so if you plugged in the letter a, this would be 3 times a minus 1, which would look like that. So this is just an example of a function f. Here's another example of function g. So we use letters just like we do with variables to represent functions, and then we use this notation of parentheses followed by that. So don't get this confused with g times x. That's not what it is. This in typical terms is just that it's some function, and this is my placeholder that gets filled into the parentheses. And in this case, the function is in terms of x. So looking at this, what do you think would happen? G of 0 would be what? Well, it's 0 squared plus 1. So 0 times 0 is just 0. Plus 1 would be 1. So this is my input is 0. And this is the process it's going to go through is the function g, which is just to square something and add 1 to it. And then I get an output. So here, this was also an input. And I get an output of 1. Okay. Now, so this would be negative, the g of negative 5 would be negative 5 squared, and everything goes inside the parentheses. It's like that x is a placeholder for this whole value of negative 5 plus 1. So negative 5 times negative 5 is positive 25, plus 1 would be 26. And then g of a would be a squared plus 1. So I can't simplify it any further. It would look just like that. Okay, now let's compare to a non-example. So we do have equations that are not functions in the case of some relations. All relations are just equations that relate variables to each other. Okay, so there are relations that are not functions. For example, we have x times y is 24. Now, I could come up with single input, single output, a table like this. So let's say I input my x value. Let's just say I pick some things that work. So 3 times what number would be 24? Well, 3 times 8. And what if I picked 6? Well, 6 times some number is 24. 6 times 4, right, would be the single output that would work. So there are points where it is a function, but there are points that would make it not a function. So what if I put in a single input of, say, x equals 0? Well, 0 times what value would give you 24, right? You can't come up with a value that would make it 24. So this doesn't exist. So at the value of 0 for x, it's not a function, right? So you don't have an output. It's not a function at that point. Okay, so maybe you can rearrange the equation and say, okay, y, I'm going to divide both sides by x. Y is equal to 24 divided by x. So maybe you could say y of x, this is the function y of x, is equal to 24 divided by x, so long as x does not equal 0, right? Now this, I've turned it into a function, so that's how that would look. And you could do x as a function of y, just reverse the variables, right? Divide both sides by y, and you get x is equal to 24 divided by y, so long as y does not equal 0. This would be another function, and actually I would write, instead of this, I would write x of y to make it a function. Okay, another example, what if I had this relationship that if I square this number, it's equal to some other number? Well, I could do a little table of values. What if I picked an x value of, I don't know, 16, right? Well, the y that would make that true would be 4 would be one possibility, right? But I could also put in a value of negative 4 and get the same thing. So, right, negative 4 times negative 4 is also positive 16. So this is a case where there's two different outputs for a single input. So that's not a function. Okay, but if I looked at it the other way, if I put y as my variable that I'm plugging in for, right? So y of x is not a function, right? So I plug in different value, a value for x, I could get two different solutions. But if I had x as a function of y, right? So x, and then I'm going to plug in my y value. So let's say I plug in 4 for y. Then what value do I get out for x? 4 times 4 is 16. And there's only one value that gets produced going that way, right? If I plug in, I don't know, 7, then 7 squared is 49. So I'm okay. But if I initially put in 49 for x, I could get 7 or I could get negative 7. So x of y is a function, but y of x is not a function. Okay, hoping that makes sense. You could come up with some values that don't exist, like what if I said x was negative 16, right? So you cannot get a negative number out of squaring two positive numbers. So that's another case where it's not a function in terms of x. Okay?